Practical research presentation of microplastics identification found in gastrointestinal tract of Chanos and Oreochromis niloticus from Marikina wet markets by 12 STEM 2301, group number 4.
Microplastics were tiny plastic particles, typically less than 5 mm in size, resulting from the breakdown of larger plastic debris. These particles were small enough to be ingested by marine organisms, leading to a bioaccumulation in aquatic food chains. As plastic waste continued to increase globally, MPs remained a pervasive environmental pollutant, posing threats to ecosystems, wildlife, and human health, by Barboza and Gimenez 2015. In the Philippines, markets such as Concepcion Uno Market and dry markets, New Parang Market and Marikina Public Market remained essential sources for seafood for local communities. Hernandez M. et al. 2020. Yet, rising urbanization and pollution made these markets point of entry for microplastics into the food supply. Fish like Chanos or milkfish and Oreochromis niloticus or Nile tilapia, staples in food diets facing growing risk of contamination. Cole M. et al. 2011. This study addressed the knowledge gap by investigating these markets to identify the presence of microplastics, specifically the type, size, shapes, and color, and to evaluate their implications for the local aquatic ecosystem and public health. These findings were expected to raise about microplastics contamination in seafood, ultimately contributing to efforts in promoting sustainable development Goal 12, plastic waste reduction, sustainable seafood consumption, and environmental protection strategies.
The purpose of the study was to identify and examine the presence of microplastics in two commonly consumed fish, Chanos and Oreochromis niloticus in Marikina City, Philippines. This study analyzed the types of microplastics found in gastrointestinal tract of Chanos and Oreochromis niloticus and their implication for the aquatic environment. We collected fish samples from wet markets in Marikina City to assess the extent of contamination and characterize the microplastics, focusing on their types, sizes, shapes, and colors. The study specifically looked at the tiny particles resulting from the breakdown of plastic-based waste and the presence and characteristic of microplastic detected in the fish samples, as well as their potential implication for environmental health.
Now for our research questions, first we have, what are the identified types, shapes, and colors of microplastics in Chanos and Oreochromis niloticus? Second, what is the mean number of microplastic particles per individual in Chanos and Oreochromis niloticus samples from Marikina wet markets? And lastly, what is the mean length of microplastic particles identified in the digestive tracts of Chanos and Oreochromis niloticus? This study examines the presence of microplastics in Nile tilapia and milkfish, two widely consumed fish species. By identifying their exposure to microplastic pollution, this research highlights potential risks to aquatic life and human health. The findings contribute to food safety, environmental conservation, and policy making, emphasizing the need for stricter waste management and sustainable aquaculture practices. This study also informs stakeholders such as policymakers and environmental groups on mitigating microplastic contamination. Ultimately, it raises awareness of plastic pollution's impact and promotes responsible environmental stewardship to protect both marine biodiversity and public health.
This study investigated microplastic contamination in Chanos milkfish and Oreochromis niloticus or Nile tilapia from Marikina City wet markets. It focused on identifying and analyzing microplastics in this commonly sold species. The study examined 40 samples but excluded 385 due to practical constraints. It did not address internal microplastic impacts on fish, human health, or the environment. FTIR spectroscopy was not used, The scope was limited to fish samples from Concepcion Uno Market, New Parang Market, and Marikina Public Market, excluding other aquatic organisms or regions.
Conceptual framework. Figure 1 illustrates the process for identifying microplastics in the guts of two fish species, Chanos and Oreochromis niloticus, which were collected from various wet markets in Marikina. The study involved sample collection from three specific market locations: Concepcion Uno Wet and Dry Market, Marikina Public Market, and New Parang Market. The framework was organized to depict the sequence of steps undertaken in the investigation, starting with the selection of fish species and market sites, followed by a series of procedural steps for microplastics detection. These procedures included sample collection, visual identification of microplastics, data recording and classification, analysis and interpretation of findings, and validation to ensure the reliability of results.
The study employed a descriptive quantitative design to identify and quantify microplastics. Descriptive studies measured phenomena in their natural state without researchers' intervention, thereby not altering behaviors or experiences, according to Price and Lovell 2018, page 41, which allowed for an accurate representation of the current state of microplastic contamination. 3 wet markets were chosen for sample collection due to previous findings of microplastic contamination in fish from Marikina City. First one is Concepcion Uno Market, located at 169 E. Santos Street. This market is a vital resource for the local community, offering fresh produce, meat, seafood, and home goods. Second, New Parang Market, situated at Gen B.G. Molina Street. It serves as a hub for fresh produce, dry goods, and daily essentials. Third, Marikina Public Market, found at Captain Benchong Street in Barangay Santa Elena. This central hub attracts both residents and visitors from neighboring areas. 2 fish species were collected: Chanos, known for consuming cyanobacteria, diatoms, and small invertebrates, and Oreochromis niloticus, a globally significant aquaculture species providing affordable protein. This study employed a descriptive quantitative design to examine microplastic contamination in Chanos or milkfish and Oreochromis niloticus or Nile tilapia from Concepcion Uno Market, New Parang Market, and Marikina Public Market in Marikina cities. Samples were collected using a purposive sampling based on type, size, and color. The fish organs were dissected and treated with a 10% potassium hydroxide solution at 60 degrees Celsius for 48 hours, followed by a density separation using sodium chloride solution. Finally, microplastics were visually identified and classified under a compound microscope at 10x magnification. The data collection procedure involved fish collection from wet markets, dissection, chemical digestion, filtration, and visual identification. The researchers conducted field observations to gather insights on the sources of fish sold in wet markets in Marikina City.
Microplastic characterization. The potential particles will be identified by their color, size, and type. This will be sorted in filters that will be used in the process. The researchers will also count the numbers of microplastics presented in each sample, and will be pictured by observing which type and size it is presented. Visual identification. Potential plastic fragments will be determining the following criteria established by Lasher and Andy Tacarina et al. 2017, which defines thickness and color, organic substances, and should show a glossy appearance.
For criteria for finding microplastic, pellet will be identified by their small rounded shape. Fragment will be recognized by their irregular and broken appearance. Fiber will be characterized by their long and thin flexibility shape. Film or filament will be recognized by their thin and flat and often as transparent.
The size of each particle was measured using the 10x magnification, calibration slide, and scale bar function according to Bavo DeWitt 2022. Finding the measurement by using 0.1 mm calibration slide with its total of 10 stage units that has a 1 stage unit is equal to 100 micrometer.
In visual identification in microscope, 13 stage units is equal to 1,300 micrometer in tilapia mouth. In 4 stage unit is equal to 400 micrometer in tilapia intestine, also in tilapia rectum. These are the images during the chemical laboratory. First is 300 ml of 10% potassium hydroxide was added to the 100 ml beaker. Second, after cooling down, 5 ml of 30% hydrogen peroxide was mixed in. The beaker was filtered using a wash bottle and a 120 mesh filter. The fourth one, through the separation was achieved by filtering the beaker using 60 mesh and 120 mesh filters. And lastly, microplastic were observed through 100 times magnification microscope and calibration slide.
For this section, we gathered the results of a total of 40 fishes from Concepcion 1 Wet Market, Marikina Public Market, and New Parang Market were inspected under a microscope to test for the presence of microplastics in the gastrointestinal tracts of Chanos and Oreochromis niloticus. The samples were 20 each Chanos and Oreochromis niloticus. Microplastics were observed and measured into two size categories, 125 to 250 micrometers, 250 to 1,500 micrometers, adopting the methodology of Lusher et al. 2017 and Desforges et al. 2014. Figure 7 reveals that the Concepcion 1 Wet Market has the highest microplastic contamination, with 8 out of 20 fish samples affected. Specifically, 50% of Chanos and 30% of Oreochromis niloticus from this market contained microplastics. In comparison, Marikina Public Market had lower contamination levels, with 50% of Chanos and 25% of Oreochromis niloticus affected. New Parang Market had no contamination. The percentages were calculated using the formula actual value divided by total value multiply by 100.
Table 1 shows that out of 40 fish samples collected from 3 wet markets in Marikina, 26 microplastics were detected. The Marikina Public Market had the highest contamination with 17 microplastics, followed by Concepcion 1 Market with 9 microplastics. In contrast, no microplastics were found in fishes from New Parang Market. These findings suggest that fish from the Marikina Public Market are more exposed to microplastic contamination compared to the other markets.
Based on our analysis, we found that fiber was the dominant ingested microplastics that accounts up to 26 found MPS, and the dominant found organ with MPS is the stomach for both species. Additionally, the dominant color is blue that ranges up to 54%, while red being the lowest with 46% out of 26 species. Our findings directly address our research questions and provide valuable insights into microplastic ingestion in Chanos and Oreochromis niloticus. For example, we observed that blue microplastics were the most frequently ingested, accounting for 54% of the total, which aligns with previous studies by Abinion 2020 and Besa 2018. Additionally, fibers were the most dominant type of microplastic found, which supports existing studies.
Figure 9 shows the gastrointestinal tracts of Chanos to analyze microplastic ingestion. Using a 10 times magnification lens, microplastics of various sizes were identified. 1,600 micrometers in the mouth, 800 micrometer in the stomach, 500 micrometers in the intestine, and 600 micrometers in the rectum. These were classified as microfragments based on Desforges et al. 2014. The study found that microfibers, particularly blue-colored ones, were the most common types of microplastic, making up to 80 to 90% of samples. This aligns with previous research identifying microfibers as a major pollutant from sources like fishing gear, shipping, and offshore industries. The findings emphasize the need for further research and improved pollution control strategies to mitigate plastic waste in aquatic environments. Figure 10 showed the gastrointestinal tracts of Oreochromis niloticus, indicating ingestion from contaminated water or plastic debris, and the microplastics found in tilapia were documented and analyzed thoroughly. They were classified based on size and closely examined. The varying shapes and sizes suggested multiple pollution sources, such as degraded plastics and artificial textiles. The results point out the need for further research on microplastics ingestion in fish and its ecological impact. The data underline the need for pollution control strategies to reduce plastic waste in aquatic environments. And that concludes our research presentation. Thank you.